Good morning all. So today we will start with the moment of inertia of a composite section. So composite section means that is not a plane section. That is the combination of more than one section. That is known as composite section. So in that case, the value of moment of inertia along the any axis, that may be in y axis or in x axis, is find out by the theorem of parallel axis. So according to the theorem of parallel axis, the formula will be IAB is equal to IG plus AH square, where the IG is equal to moment of inertia of the section about its center of gravity and parallel to the axis, and the small a is equal to area of the section, and this small h is equal to distance between the required axis and center of gravity of the section. So now we need to calculate the moment of inertia of a composite section, which is an unequal angle section. So here is the numerical, which is find the moment of inertia about the centroidal along x-axis and y axis of the angle section as shown in the figure. So here is the figure. So you can see the angle section is consist of two parts. One is the wave portion and another is the flange portion. So the dimension is this much. So to calculate the moment of inertia, first of all, we need to find out the center of gravity. For any section, to calculate the moment of inertia, we need to calculate the center of gravity. Then after that, we can find out the moment of inertia about any axis. So first of all, we need to find out the center of gravity. So as we know that the angle section is one kind of unsymmetric section, so that's why in this case we have to calculate the center of gravity along the both axes. That means along the y axis and also along the x axis. So first of all, we need to find out the center of gravity along the y axis. So according to the procedure, first of all we need to divide the whole section into many parts. So according to this section will be divided into two parts. So this is the section 1 and this is the section 2. So for the section 1, the area is equal to B into D, that is 100 into 20, which is equal to 2000 mm square, and the center of gravity of the section 1 with respect to reference line is equal to D by 2. So the D value of section 1 is equal to 100. So y1 is equal to 100 by 2, which is 50 mm. Similarly, for the section 2, the area is equal to 60 into 20. Hence, the value will be 1200 mm square. And the y2, that is the center of gravity of the section 2 with respect to the reference line, is equal to D by 2. and here for the section 2 the d value is 20. Hence d by 2, that is 20 by 2, which value is 10 mm. Now to find out the center of gravity along the y-axis, the formula will be y bar is equal to a1y1 plus a2y2 divided by a1 plus a2. So by putting the values, we have the answer, which is 35 mm. So now for the calculation of moment of inertia, we need to find out the moment of inertia about its center of gravity. So as we know that for the angle section there are two parts and both are rectangular parts. So that's why for each section the value of moment of inertia is equal to bdq by 12. So here for the section 1 the value of b is 20 and the value of d is 100. So that the moment of inertia for section 1 is equal to 20 into 100 to the power 3 divided by 12, which is 1.667 into 10 to the power 6 mm to the power 4. Now the value of h is equal to 50 minus 35, that is the difference of y bar and y1. Hence the value of h1, that is for section 1 the value of h is equal to 15. So according to the theorem of parallel axis, the formula will be Ig plus AH1 square. By putting all the values, we will get the moment of inertia for the section 1 is equal to 2.117 into 10 to the power 6 mm to the power 4. Similarly, for the section 2, the value of center of gravity is this much and the value of moment of inertia is equal to bdq by 12. So by putting the value, we have 0.04 into 10 to the power 6 mm to the power 4. Now the value of h for the section 2, which is the difference between y bar and y2. So now the h2 value is equal to 25. So by putting the parallel axis theorem, Ig plus AH square for the section 2 is equal to 0.79 into 10 to the power 6 mm to the power 4. So now the moment of inertia of the whole angle section about the x-axis is equal to the moment of inertia of the section 1 plus the moment of inertia for the section 2. So by adding the two moment of inertia, we have 2.907 into 10 to the power 6 mm to the power 4. Similarly, along the y axis, we have to follow same procedure, but only the axis will be different. So hence, we have to calculate the center of gravity first. Then after that we can calculate the moment of inertia. So here for the section 1, the area will be same as per the x-axis. So here area is equal to 2000 mm square and the center of gravity of section 1 along the x-axis is equal to 20 by 2, which is 10 mm. Similarly, for the section 2, the area will be 1200 mm square and the center of gravity of the section 2 with respect to reference line is equal to 20 plus 60 by 2, which is equal to 50 mm. So now, as per the center of gravity along the x-axis, the formula will be x bar equal to a1 x1 plus a2 x2 divided by a1 plus a2. So by putting all this formula and values, we have the center of gravity along x-axis is 25 mm. Now we can calculate the moment of inertia along the y-y axis. So first of all, the moment of inertia of the section 1 along the center of gravity is equal to bdq by 12. So here for the y-y axis, the value of b is 100 and d is 20. So that's why the value is 100 into 20 to the power 3 divided by 12, which value is 0.067 into 10 to the power 6 mm to the power 4. So now we have to calculate the value of h for section 1. So which is the difference between x bar and x1? So here the x bar value is 25 and x1 value is 10. Hence the value of h for the section 1 is equal to 15 mm. Now according to the theorem of parallel axis, we have to put the formula Ig plus AH square. So for the section 1, we have the value of moment of inertia is equal to 0.517 into 10 to the power 6 mm to the power 4. Similarly, for the section 2, the value of Ig2 is equal to bdq by 12, which is 20 into 60 to the power 3 divided by 12, which value will be 0.36 into 10 to the power 6 mm to the power 4. Now, the value of h for the section 2 is the difference between x bar and x2. So here, the value of h for section 2 is 25 mm, and according to the axis of theorem of parallel axis, the value of moment of inertia for section 2 is equal to Ig2 plus A2H2 square. So by putting all these values, we have 1.11 into 10 to the power 6 mm to the power 4. Hence, the total moment of inertia of the whole angle section is equal to the moment of inertia of the section 1 plus the moment of inertia of the section 2. Hence, by adding both the moment of inertia, we will get the moment of inertia along the y-y axis as 1.627 into 10 to the power 6 mm to the power 4. So this is all about the moment of inertia of the composite section by the help of theorem of parallel axis. So today this much. Thank you.